Alright, I'm back. Don't remember what I was saying. But, I think I was just oh yeah, I remember now. I was saying that from now on, you're going to start seeing a lot more trig functions and derivatives of trig functions. So, if you haven't started yet, you need to start trying to memorize your derivatives of trig functions. All of them. I don't know, come up with a way. Remember these? Know them. Where's my finger? Oh, that's weird. There they are. Yep, there we go. Oops. Oh, wrong one. Know them. Or start memorizing them. Okay, so let's do another example of this chain rule. Where's my next one? Alright, let's just try y equals the sine of 3x squared plus 1. If you want a second to try it on your own, someone run up to the computer right now and pause this, because I just figured out that I can't pause on the iPad. It'll just stop and I'll have to make a new video, and then you'll have to click another link again and blah blah blah. So pause it right now if you want to try it on your own first for a couple minutes. So do that, because I'm going to give you the answer in 3, 2, 1. Alright, so here's how you do it. Y prime. Inside is obvious on that one, inside the parentheses, right? So the derivative of the outside, if I ignore that stuff, it's like you can just think of it as sine of x. So the derivative of that is just cosine. Leave all this stuff inside. Multiply it by the derivative of the inside. Derivative of the inside would just be 6x. 1 would go away. So there it is. Your derivative is just 6x times the cosine of 3x squared plus 1. Simple as that. In the book, there is another way of doing it, where you actually use a little bit of substitution, and you'll see on the homework, it'll tell you in the directions, it'll say use the given substitution in the chain rule to find the derivative. You don't have to do it that way. You could just do it the way I just showed you. What they mean by that, oops, finger got in the way. What they mean by that is like, let's say your function was y equals the sine of x squared plus x. Well, to use substitution, you say, all right, here's the stuff inside the parentheses. Let's just pick some arbitrary letter. They use u, and let that equal x squared plus x. Well then, if u equals that, now our function is y equals the sine of u. And if you look at the definition of the chain rule, it'll tell you that, iPad's getting in the way of my hand again, dy dx, so the derivative of this one, is the same thing as dy du, which would mean the derivative of this one with respect to u times the derivative of u with respect to x. So basically just what we were doing before. The derivative of this one, or the outside, times the derivative of this one, the inside. And so they go, oh, okay, well, that means dy dx, so derivative of y with respect to x equals, well, dy du, so the derivative of this one with respect to u, derivative of sine is just cosine of u. Well, now du dx, so the derivative of that one, so I'm going to multiply by the derivative of that one, 2x plus 1, Now, there's my answer, but I got to get rid of that u. Well, I know u equals x squared plus x, so the cos of x squared plus x times, and I'll write it out front, 2x plus 1. 2x plus 1 times the cosine of x squared plus x. So, I mean, it's the same thing. It's just using this u substitution. You can use that if you want. It may become easier for you when we start having to do the chain rule more than once, which is next. There's a big page here. Take this down. Alright, so if we have to do it more than once, a function like g of t, and this is one of the examples in the book, tangent of 5 minus the sine of 2t. I want to find the derivative of that. Well, what you'll notice is this is a composite function, tangent of this stuff, and then if I ignore that, I've got another composite function here with the sine of 2t. So what I got to do is do the chain rule twice. So I'll start, alright, the derivative of g of t is, so here is my inside here. So if I ignore that, the derivative of just tan of x is secant squared. So I'll have secant squared of all this stuff left in there. And then I remember I have to multiply the derivative of my outside times the derivative of the inside. Well, the derivative of the inside, I don't know that. So I'm going to write, I need to take the derivative of the inside. Okay, so next step. This part's done. I can leave that out there. So secant squared of 5 2t. That's just chilling out there. Now I got to do the derivative of that. Well, okay. So my inside piece on this one is the 2t. The outside is the 5 minus sine of x. So the derivative of the outside piece, 5 minus sine of x, so derivative of 5, it just goes away. So basically the derivative of the negative sign would be negative cosine, and I leave the 2t there. Now the derivative of the inside, so I have to take the derivative of the 2t. Derivative of 2t is 2. And now I'm done. So I can write it a little better. I've 2 times negative cos would be negative. It doesn't matter what order you really write it in, but I am going to multiply the 2 by that. So negative 2 cosine of 2t. I can put that in parentheses if I want, and then secant squared of 5 minus the sine of 2t. A lot of parentheses, and that is the derivative of that. When it says to, in the book, if you are unsure of your answer, use n derivative to support your computation. So what they're saying is, I think this is my answer, but I'm not sure. So what I can do, where'd my graphing calculator go? I can take this, I can plug that into y1, get out of there. Alright, and now I'll take the n deriv at a point. I don't know, pick a point. I will pick pi. I get negative 24, blah, blah, blah. Well, so now, okay, if I take my derivative and plug in pi for t, I should get negative 24, blah, blah, blah. So I can just check it now. I'll go parentheses, negative 2 cosine of 2 pi. Alright, I'm just plugging in pi for t. Times the secant squared. Ah, no. That's going to be ugly. Secant's 1 over the cosine, so I need to go 1 over, I'm going to use parentheses, cosine 5 minus the sine of 2 pi, close that, square it, close that, got it. So that one's kind of a hard one to check because there's a lot of parentheses going on, you got to be careful, but it worked. I think your homework ones, most of them are a little easier. I gave you a couple hard ones, but that's it. So here it is. 4.1, number even a couple odds in there. So it's 2, 5, 10, 16, 22, 23, 24. So hopefully this worked out and I wasn't shaking around too much. Kind of cool. We got a guest appearance by a school board member on there. So I guess that's it. Trying to think if I have anything else to say. Nope. Hopefully this worked. So yeah, this will be due Monday like normal. So do it. Looks like I only filmed here for about 20 minutes, so you should have plenty of time to work on it now. So see you Monday.